Let's go ahead on to the product rule homework questions. And for the very first example, I need to find the derivative using the product rule. All right, so here we go. The derivative would be y prime equals. All right, so let's take the derivative of the first term here. So the derivative of 3x squared plus 2 is going to be 6x. So 6x is the first derivative, times by the second term, which is going to be 2x cubed minus 1. And then plus the first term, which is going to be 3x squared plus 2. And then we take the derivative of the second term, and the derivative of 2x cubed minus 1 is going to be 6x squared. And that right there is your derivative for the very first question. And let's move on to question number 2. So for question number 2, let's take the derivative of the first term. So that's going to be 2x times the second term, which is going to be 3x squared minus 2x. And then plus the first term. Now the first term is simply going to be x squared minus 2. And then we take the derivative of the second term, and the derivative of the second term is going to be 6x minus 2. And that's your final answer. No need to simplify. Let's just move on. All right, for question number 3, before we take the derivative of this question, let's rewrite the radical into a power. So this part right here, the second term, let's rewrite that as x to the power of 1/2. Okay, let's go ahead and find the derivative now, so y prime. So using the product rule, I take the derivative of the first term, and that's going to be 2 times the second term, which is going to be x to the power of 1/2, plus the first term, which is going to be 2x minus 1. And then I need to take the derivative of this second term, and using the power rule, the 1/2 would come in front, then x, and then you subtract 1 from the power there, so 1/2 minus 1, which is the same thing as 1/2 minus 2 over 2, is going to be negative 1/2. Okay, so this answer is technically correct, but however, let's just go ahead and just clean this up here. So this would be y prime equals to 2 times, now this part right here is going to be root x, x to the power of 1/2 is root x, plus, and then 2x minus 1. And then finally, this next part here in purple, let's just go ahead and simplify this properly. It would be 1 over 2 root x. Okay, so this 2 right here is that 2 right there, and this x to the power of negative 1/2 is that part right there. And that's your final answer for question number 3. Okay, let's move on to question number 4. And for question number 4, let's rewrite this as 3 minus 2x times x to the power of 1/2. All right, now let's go ahead and find the derivative now. And using the power rule, I need to take the derivative of the first term. So the derivative of that is going to be negative 2 times the second term, which is x to the power of 1/2, plus the first term. The first term is just 3 minus 2x. And then finally, let's take the derivative of this second term, and just like the previous problem, the 1/2 would come in front, and then x, and this will be the power of negative 1/2, right? So it's the same thing as 1/2 minus 2 over 2, which is 1/2 minus 1 essentially, and this will be negative 1/2. So this will be the power of negative 1/2. Okay, and then from there, let's just go ahead and clean this up. So it'll be y prime equals to negative 2, and then this will be root x. So x to the power of 1/2 is going to be root x, and then plus 3 minus 2x. And then this part right here in purple, let's write that as 1 over 2 root x. And once again, this 2 right here is that 2 right there, and this x to the power of negative 1/2 is this green part right there. And that should be your final answer for question number 4. Okay, so move on to some tangent line problems. So for the next question, I need to find the equation of the tangent line to this curve at x equals to 3. Okay, so whenever you have a tangent line question, let's go ahead and write out the equation of the tangent line, which is y minus y1 equals to m times x minus x1. Okay, and now we're given x equals to 3. So let's go ahead and evaluate f of 3 here. So my plan right now is I want to find the values of y1 and x1. X1 is going to be 3, but let's go ahead and find the value of y1 by plugging 3 back into the original equation. So this will be 2 times 3 plus 1 bracket 3 minus 4. All right, so we're essentially plugging in 3 into the original equation. So f of 3 is going to be 6 plus 1 times 3 minus 4, which is negative 1, and that's going to be 7 times negative 1, which equals to negative 7. Okay, so that is the y1 value. So if I go ahead and update my equation here, it'll be y, and then since this is a minus 7, this will be plus 7 equals to m bracket x, and then I have a 3 here, so this will be minus 3. Okay, so that's step number 1. We find x1 and y1, and then after that, let me just erase all of this. And then our next goal is I want to find the value of m. So now I need to take the derivative and find the derivative value when x equals to 3. Okay, so going back to my original function here, let's go ahead and find the derivative now. So y prime, so I want to find the derivative of the first term. So the derivative of 2x plus 1 is simply going to be 2 times x minus 4 plus, and then the first term, which is going to be 2x plus 1, and then I times by the derivative of the second term, and the derivative of x minus 4 is just 1. Okay, and after that, let's find the derivative value at x equals to 3. So anytime I see an x here, I'm going to change all these x's with a 3. So this will be 2 times 3 minus 4 plus. Okay, if I plug in a 3 here, this will be 2 times 3, which is going to be 6. So 6 plus 1 times 1. Okay, and let's go ahead and evaluate this. This is 2 times negative 1 plus 7 times 1. And once we finish that, that's going to be negative 2 plus 7, and negative 2 plus 7 is going to be positive 5. Okay, so now that we have positive 5, I can plug in 5 back for the letter m there. So this will be y plus 7 equals to 5 bracket x minus 3. And there you go, that's your final answer for that question there, the tangent line question. Great, so we're moving along here. Let's move on to the next question here. Find the equation of the tangent line. So find the equation of the tangent line to the curve this at x equals to minus 1. All right, so step 1, whenever I have the tangent line problem, I will go ahead and find or write out the equation of the tangent line like that. And since we're given the value of x here, that's this value right there, so x1 will be 1. Let's go ahead and find the value of y1 now by plugging in 1 back into the original equation. So let's evaluate f of 1 here. So that would be the square root of 1 plus 1, bracket the square root of 1 plus 3. So the square root of 1 plus 1 is going to be 2, and the square root of 1 plus 3 is going to be, square root of 1 plus 3 is going to be 4. So 2 times 4 is going to be 8. It's going to be 8. Okay, so going back to my equation of the tangent lines, this will be y minus 8 equals to m bracket x minus, and this 1 will be over here, so x minus 1. Okay, so there's the first part of the equation of the tangent line, finding the values of y1 and x1, and then I need to find the value of m. All right, so the derivative value at x equals to 1. Okay, in order to do that, I need to find the derivative of my original problem here. Okay, so if I find the derivative right here, let's go ahead and rewrite this in terms of a power here. So this will be x to the power of 1/2 plus 1 bracket x to the power of 1/2 plus 3. Okay, and after that, let's find the derivative here. So using the power rule, this will be 1/2 x to the negative 1/2 times the second term, which is x to the power of 1/2 plus 3, plus the first term here, which is going to be x to the power of 1/2 plus 1. And then we take the derivative of the second term over here to complete the product rule, which will be 1/2 x to the power of negative 1/2. Okay, so throughout this homework video guide, you do have to be very comfortable with taking the derivative of x to the power of 1/2. So make sure that this part right here becomes automatic as you go through the homework problems here. Okay, so what I would recommend next is let's just go ahead and simplify this. This is going to be 1 over 2 root x times root x plus 3 plus, and then this part right here, I'll leave that as root x plus 1, and then this part right here, I'll leave that as 1 over 2 root x. Okay, so I'm changing my powers back into radicals, and then finally, let's go ahead and evaluate f prime at f prime of 1. And what that really means is anytime you see an x here, all these x's are going to change to this value of 1 right there, right? So we want to find the derivative value when x equals to 1. Okay, so Let's go ahead and do that now. This will be 1 over 2 times root 1 times root 1 plus 3 plus root 1 plus 1 times 1 over 2 times root 1. Okay, let's go ahead and simplify this now. If I evaluate that, that's going to be 1 over 2 times, well, root 1 plus 3 is going to be 4, plus root 1 plus 1 is going to be 2, and this expression right here is something going to be 1 over 2 times 1, which is 1 over 2. So I'll leave that as 1 over 2 here. Okay, all right, we're almost done here. 4 divided by 2, that's going to be 2 plus, and then these 2's cancel out, giving that simple 1, so 2 plus 1 is going to be 3. So after all that work, the derivative value when x equals to 1 is 3. Okay, and then I take that 3, and this number right here becomes a 3, right? So, and just fill in the rest here. All right, so y minus 8 equals to 3 times x minus 1. Okay, that's great. Let's move on to example number 3 here, some of the table questions here. Let me just erase all this, and let's take a look at this problem right here.